All right, so what we're going to do this time is I'm going to create a bunch of objects. I'm going to start demonstrating a quick bit of what was called the Flashback utility, just kind of an introduction. Then I'll leave that up to you to go off and Google and find out more about it. And then I also want to basically add some constraints to the model and let you sort of see how it plays out in the diagram. And so anyway, so it's kind of we're going the opposite direction as we went before. So if you're playing at home, I do actually have this script on the course site, which will basically drop and will create. Remember, this is a script, so if it tries to drop something and it's not there, you'll get an error message, but it's going to continue to the next line and it's just going to plow through the whole thing. So let's just, and at this point, currently, there are no tables in my schema. So I'm going to go. All right. And so what that does is you can see there's the error messages as it's trying to create something that doesn't exist. And there it is when they do exist. Now, if this is centuries after this course, or you just were never in it and you're just interested to try this on your own, I would suggest that you could go out to Live SQL and do a search for HR objects and data for Live SQL. This is free. You just have to create an account. And if you basically took this and you ran it either in Live SQL or just basically grabbed all the code from in here, you would actually have your own HR schema. Now it would be a complete schema, so bear that in mind. We're actually kind of cheating. We're just using bits of it, and I'm going to complete some of it manually. But it's a good place to start. And you know what you're doing. You can basically create yourself an HR schema, put your objects in there, then create yourself a play schema like this one, and then you could run this script, assuming you had the permissions. A little bit more challenging, but there you go. Or you can just watch this video and be amazed. So now if I was to go up to the table and I was to go refresh, there are all the objects. And now we're kind of ready to start. One thing to create a data model so we could actually see it. Now I did it over there already. It takes a little bit of time, but you can go data modeler, import from the data dictionary. It's got access to all the connections that you had already. So you can go next. And then you go find the schema that you're playing in, and then you go next. Next one's the import. This is going to take a little bit of time, but basically find your objects, and you can basically turn them on or off with that. Then you go next, and then at that point you go finish. And after a bit, you would merge yourself into this kind of diagram. So these are all the objects, and what I want you to note is that they're not connected in any way. We don't have any primary keys or anything. And the only thing they kind of do have is these little asterisks. And if you were to go check on why it's got an asterisk, it's got an asterisk because it's not null. That's why it's got an asterisk. All right. So when you basically say in your create table statements, when you make something not null, that is a constraint. It's a check constraint. We'll talk about those in a few minutes. But that basically, that little star, what that does in the code is it generates a not null for that particular column. All right, so let's have a little bit of fun first with this. First thing I'm going to do is I'm going to demonstrate a little bit of a flashback. So I'll remind, or maybe just say to you, if you haven't seen this before, that if you drop a table, drop table regions. So I'm going to drop this table over here. If I go drop, it drops, and there's no way to undo that. It is now, in theory, forever gone. Those of us that know anything about DML know that if you insert, delete, and update, a lot of times you can undo it by rolling it back, which is what that is. See right there, roll back, or you can save it permanently, which is what the commit is. So what if you actually want to get it back? Well, the cool part, at least in an Oracle database, is that they actually do have something in here called a recycle bin. So if you go to the recycle bin and you have a look at it, you'll see that there's one wonderful object in the recycle bin. That's its actual name, but it also knows the original name, and it knows what happened to it. It was dropped, and that it was a table. And there's some other cool stuff too, like when it was dropped and so on. So this actually does exist in the recycle bin. So you can get it back, and how you can get it back is you can go flashback. So flashback, okay, that's not gonna work. Flashback, click, flashback. And then what do I get a flashback? There's a few options there. You can see database, standby, and table. Table, and what's the object? You got to use the name, its original name, regions. And then at this point, it's asking for sort of a time. And in this case, I'm going to go time, so before drop. You'll notice that there were some other options there. So if I go flashback to before drop, it says, regions. Okay, that was kind of goofy. There it is. Flashback succeeded. Now, if we go, what's in the recycle bin? Nothing's in the recycle bin. And if I was to go select asterisks from regions, now the table is back alive and well. So that's a neat thing you can kind of, practice with your friends. Again, maybe do some Googling. Notice that when I was typing flashback, there were certain autocomplete things that were coming up, which is pretty interesting. And I mean, look at what this sort of implies. I don't think any of you will have the access to do this, but this is kind of implying that you could basically flash back the database to yesterday, right? So that's pretty darn cool. And if you ever get your own database, that's something to kind of mess around with. All right, so anyway, so there's the regions table, and I believe it's all back now. Just do a quick little refresh here, refresh, and yes, it's back. All right, so let's have some fun now with the whole idea of some constraints. So right now, I'm going to play a little bit with the employees table, right? No constraints. In fact, even the employee ID is allowed to be null, right? So even the employee ID is allowed to be null. So if I was to add this statement, alter, actually I'll use the case and get my mouse out of the way. Alter table employees, add a constraint, which I'm going to call employees, that's the table, employee ID, and then what kind of constraint is it? It's a PK. What is it? It's a primary key. What's a primary key? The employee ID. Semicolon. So I run this thing, and we can see it was altered. And now, if I wanted to sort of see the impact on the diagram, I'm going to go do my little import, data dictionary, do this, go next, and find me, go next, and then I'm going to go. Well, I tell you what, this time, I'm going to just grab only the employees. It might be a titch faster, although I might have just lost that speed when I did that. Chunk, chunk, chunk. It's generating the design. It went out to the data dictionary of the database. It's now bringing it in, and what I'm hoping to see is it's going to merge its great discovery into that diagram. And now we've got both a P showing up and an asterisk showing up. And if I was to go look at the DDL preview, this thing now knows, actually it did a couple of really neat things with that, which maybe I'll talk about at some other point. But basically at this point, that's kind of the key right there. That's the code it added. It did some other stuff too, which you might want to freeze and have a look at and be amazed at. But at this point, that's all I really care about, is that it did add the constraint. And so you can kind of see the interplay between the code and the actual diagram. Also notice, I should point out, this little arrow showing up, which is indicating there's something a little bit below. And there is something below. There's my constraint, and there's my index. So it actually created an index, and you actually did see that in the code. Right there, there's an index. All right, cool. Let's go ahead and make something unique. Now we're going to make something unique. I'm going to see about making the phone number unique. Sure. That's what I'm going to do. I'm going to make the phone number unique. So it's going to be similar syntax here. I'm going to alter the employee's number. I'm going to add a constraint where this is going to be the phone number. And it's not a PK. It's going to be unique. And so what is it? This whole line over line 3 changes. It's going to be unique. And what's unique? Phone number. All right, so assuming I got my syntax right, and let's just clear this so that we can see fresh the output. It was altered. Awesome. Great. So now if I was to go and refresh my model, as we get going, I may pause videos for times like this because who needs to sit and watch me do this all over and over and over again? All right, so here again, I'm going to basically say, no, I don't want everybody. Just go out and check out the employees table, please. And so we're going to go next. It's got one table space, one user. It's going to go finish. At this point, it's running out the data dictionary, and now it's found something. Here's what it's going to do. I'm trying to think, is there anything kind of neat here to look at? Maybe not. I don't know. I'm just going to go merge. So now a U has shown up. But you can kind of see the difference now between a primary key and unique. In both these cases, the column initially just looked a lot like salary, right? It basically wasn't mandatory and didn't have any kind of a constraint designation. So what this does tell us is that the primary key has to have a value, uniques don't. And we can actually see that here. If I was to go update the employees table, set the employee ID equal to 1, you'd expect there to be a great scream from the database. And there is. There's that great scream right there telling me that constraint is violated. Awesome. If I was to say update employees, set the phone number to 1, it's got no problem. Excuse me. Of course it's got a problem. It's got unique, right? So in this case, it's saying, hey, you're violating the unique. Okay, that's great. What if I was to go, I should have done this before. What if I was to set this guy equal to null? So now what I'm doing here is I'm going back to the primary key. I'm going to basically wipe out all the values of the primary key. So here it's basically saying, whoa, you can't set it to null because that's ultimately what the primary key does. It has to have a value. And if I go phone number and I say set that to null, it's got no problem doing that whatsoever. All right, so that's the difference between a unique and a primary key constraint. All right, so let's go a little bit further now, and let's hook these two together. What we're going to do is we're going to basically say that we have a department, and this department ID is going to be the foreign key to this department ID and departments. This means that this department's got to be a primary key. So that's the first thing we're going to do is we're going to go and say alter table departments, add a constraint called departments, department ID PK, and this is a primary key. And what's the primary key? Department ID, excuse me. All right, so that will create a nice little primary key, and it did, no problem. I'm not going to bother refreshing the diagram. Just imagine that these two magic things show up over here. That's awesome. So now the next thing to do is how do we hook these two together? How do we hook these two together? So in this case, we're going to add a foreign key. We're not adding a foreign key to this table. We're adding a foreign key to this table because we want this value to hook to the primary key of that value. So what we're going to do is we're going to alter the table employees. Okay, we're going to alter the table employees. We're going to add the constraint employees, the column, department ID, FK. And then we're going to basically say, hey, this is a foreign key. What's a foreign key? Department ID. Now notice it's expecting something more, as it should, because at this point we're basically just screaming on this guy going, you're a foreign key, but we're not saying where are you referencing, where are you pointing to. So we can say that this thing references the department's department ID. Notice no more warnings. We go, and now this guy has been altered. So let's do that quick little refresh so we can see what this looks like on the diagram. So import data dictionary, me, go, and find me, go, and in this case, I'm going to only allow these two tables to get checked on here. So I'm going to go next, go. Stage 1, check out the data dictionary and load it into the memory of the ID, which is what's going on right now. And that goes away. Stage 2 is about to go and merge those changes into my diagram. I go merge, and now what it's done, we had the primary key that created a nice little index. So an index and a key, and then we got this line right there. All right. And that line, if we double click on it, we can see that this guy is looking at the department ID of one table to another. All right. There's some other things we could be doing right now, but I tell you what, actually, first of all, let's show how this works. So if I wanted to delete from the departments, so delete all the data in the departments table, it would say you can't because the employee's department ID foreign key is violated. Basically, I can't wipe out everybody here if I still have children over here. If I was to say, update employees, set department ID equal to 55, which I don't believe exists. If I go, it says you can't, right? Because if there's a 55 here, there has to be a 55 over here. The parent has got to exist, right? And then I would say the same thing if I was to go over here and say, update departments, set the department ID equal to 55, a perfectly valid number. This would probably blow up for a couple of reasons. It's going to blow up because the primary key exists. But if I was to say, okay, I tell you what, primary key, what I'm trying to say is you can't have everybody being the same value. So it's a uniqueness that got me there. But if I was to basically say, hey, just increment everything by 1, now again, we're back to violating the foreign key. So that's sort of showing the power of that little connection that we just built between these two objects. Now, but wait, there is more. There is also some data dictionary tables that we should be aware of, right? So there's some data dictionary tables we should be aware of. First of all, we have the fabulous user constraints data dictionary table. If we click on this, what this will do is show us all the constraints in our schema. Now, we have a fair number of them. If I was to say I'm only interested in employees and departments, I would go where the table name is in employees and departments, because I don't really want to see all the not null constraints in the other tables. So here we go. There's employees, maybe a nice little short would have been good too, but I'm not going to do that. All right, so first thing that might come to mind is what the heck are these? These are all the not null constraints. And so they're called check constraints. In a few minutes, I'm going to create another one. These are called check constraints. And so you can see that in check constraints, they are the ones that actually populate these two columns. All right. Then you have the P's. The P's are the primary key constraints. So there you go. Nothing really fancy going on there. Then you have a unique constraint. So the constraint type is P if it's primary, U if it's unique, C if it's a check constraint. But there is one more out there. The foreign key is an R. And notice that with the R, we get to have these columns populated, actually all 3. These are all related to foreign keys because the R means references. And I think I still have that. Yeah, references. So the fact that what we're saying is that this column references this column, that's what's being captured here with both the R and then these R columns. All right, so that's pretty cool. The other table to be aware of from user constraints columns, and I'm going to add the same thing. Add a nice little restriction here so I don't get to see everything. And we go. And what this guy does, it just gives us really the column that the constraint was on. Over here, we don't really get a sense of the column. We just know that there's a constraint on this table. I just pin that. If I go over here and run it for columns, these are the columns. And it's not too hard to imagine you could join these together. So as I alluded, these not null constraints are check constraints. And this is what happens when you don't name your constraint. this whole little bit, this line up here where I'm saying, add a constraint named whatever, that is what's stopping it from just basically taking effectively a sequential name from the database. These got to be unique, by the way, across the entire database, just so you know. All right, so awesome. So now we get that going. Let's build our own check constraint quickly. What I'm going to do is we're going to check to make sure that the salary of the employees can't be 0 or less even. All right, so right now, if I was to go update employees, set the salary equal to 0, which is, every employer's dream, we do that, it's got no problem. What we want to do now is we don't want to do that. We want to undo what that was and set a constraint in here. So I'm going to go alter table employees, add, now I'm just naming it now, constraint employees salary greater than 0 check. Right, you got up to 30 characters here, so use your imaginations. This is a check constraint, and what I'm going to do is I'm going to check and make sure that the salary is greater than 0. That'll also stop somebody from slapping in a negative salary in there. So if I go, it's got no problem. It's been altered. If I try now to set everyone's salary to 0, it basically says, no, you're violating the check constraint. And then over here in constraint land, you'll see another check constraint pop up right there, line 7. And then you can see there's the search condition. Try to remember what the difference, why there's a BC there, and I can't remember. But basically here is the code. This has to be pretty simple. It has to be pretty simple. You can compare columns to each other in a particular table. You can compare columns to a literal. You can use all those wonderful predicates like between or like or in. Not like, not in, you can use all that stuff. It's just that what you're looking at, what you're comparing has got to be pretty simple. You can't use functions like sysdate, for example, or compare it to something in another table or anything like that. There you got to use triggers, which is where we're heading in a few minutes. Or I don't know about a few minutes, but we're heading in that direction. Okay, now the last idea that I'll talk about is this whole enabling versus disabling. All right. So back over here, if I decided that, you know what, that salary's that's awesome, but I'm going to disable it, all I'd have to do is I would basically go alter table, and then wherever the constraint is, disable constraint, and then give it a name. So once I disable that constraint, it's now been altered. I'm now free to set everyone's salaries to 0. Awesome. I'm going to go now and enable the constraint. It's now been altered, and I can't update because the check constraint is violated. If I disable it, I go, it's disabled. We go and check on that constraint over here. We will see that it is in fact disabled. Right, there's our check constraint disabled. And here's a really insidious thing. Let's imagine the constraint is disabled, and I then set my salaries to 0. I then go, oh, I should enable my constraint. The database is going to be merciless with this. First of all, it's going to say you can't because the check constraint is violated. And then I go, oh, I'll just undo it. But you can't, because DDL, which is what this all is, data definition language, it commits. It commits. So if I was to go and look at my salaries now, by me undoing it, there is no undo when DDL's at stake. Come on, dude, help me out here. They're all zeros. So what I would need to do then is go throw myself on the mercy of the DBAs and maybe flashback the table or find some other way to restore my data. All right, so that was good. That was kind of the key highlights of the constraints part of the lectures.